Yes.
Thank you, and welcome everybody to my talk about mapping the cytoarchitectonic basis of social and emotional processing in the Insula. So the first question I would like to address is, why do we need new cytoarchitectonic maps in the Insula? When we look at recent functional meta-studies, for example by Florian Kurt, we will recognize that the Insula is a high multimodal brain region involved in a variety of functions, including sensor-motor functions such as interoception or pain, cognitive processing such as attention, language or memory, social emotional processing, as well as chemical perception. A well-known cytoarchitectonic work regarding the Insula was established by Mesulam in 1985, who subdivided the Insula into a granular sector, which is located in the posterior part of the Insula, followed by a disgranular sector, which covers most of the anterior Insula, and the inferior pole is subdivided into an agranular as well as an allocortical sector. Another famous postulation was proposed by Brodmann in 1909, who subdivided the Insula into a granular posterior as well as an agranular anterior part. Although the available cytoarchitectonic data provide a good general classification, we can still amend the maps, including following aspects. First of all, it should be available in a common three-dimensional reference space to allow an interference with functional or, for example, connectivity data. Besides, the map should consider inter-individual variability within the three-dimensional reference space, and we should use the latest mapping approaches in present neuroanatomy. When we compare the functional and the cytoarchitectonic modality, we will recognize that the functional diversity in the Insula is not completely reflected on a cytoarchitectonic level. So to answer my introductory question, we need new cytoarchitectonic maps of the Insula because a complete postulation for establishing a dedicated structure-function relationship is not yet available, and our study aimed at providing those missing maps. So how did we map the Insula? We investigated silver-stained histological sections of the brain and analyzed them via an optical approach in the first place. In the second step, we objectified our findings using a statistical mapping approach. And the basic idea behind this method is that every area in the human brain has got its own very specific cytoprofile. A cytoprofile is defined as density distribution over cortical depth, and you can imagine it like a fingerprint which is individual for each area in the human brain. So indeed, we selected a region of interest in the Insula, as you can see here on the right side, and we used a sliding window approach, which I will explain to you now. So within this window, which you see here, we calculated cytoprofiles for each side and compared them in a so-called distance value. To be more precise, the sliding window is moving along the cortex and calculating distance values for each position within the profile index. And the distance values are displayed in the Mahalanobis distance function, as you can see on the left side. As soon as the window passes the border, we have different cytoprofiles on each side, resulting in a statistical maxima in the distance function. We use this procedure for a varying number of cytoprofiles, so-called block sizes, to minimize the statistical noise in our approach. So all in all, one can say that we can verify the border due to calculation and comparison of cytoarchitectonic profiles. In this case, you see the example area IG3 and ID2, which can be distinguished by a decrease of granularity in layer 4, as well as a decrease of cell density in layer 3. And the border can be verified by the statistical mapping approach I just presented to you, which you can see here on the left side. We wanted to take inter-individual variability into account as well, so we mapped 10 post-mortem brains and observed each hemisphere. And the individual maps were integrated into one probability map, which is available in a common three-dimensional reference space. In this case, it's a colon, the MNI colon 27 reference space. Here you see the results of our study presented as a maximum probability map, which basically means that every voxel is allocated to one particular area. We did this because when you use the actual probability maps, you will have a lot of interference between neighboring areas. And indeed, we discovered 8 new areas in the insula, 1 new granular area, IG3, 1 new A-granular area, IA, as well as 6 new dysgranular areas, ID2 to ID7. When we consider area IG1, IG2, and ID1, mapped previously by Florian Kurt in 2010, we can now provide a complete passillation of the isocortical part of the insula. In the following slides, I want to clarify to you how we can use those new maps to establish a dedicated structure-function relationship, presented by example areas ID7, ID6, and ID4. Here you see a horizontal section of the brain, and when we select the insula as our region of interest, you are able to see that all 3 areas are part of the anterior insula, which is circumscribed by the central as well as the circular sulcus. And area ID4 is located in the superior dorsal part of the anterior insula, neighbored by area ID6, which is the largest area in the human insula, and ID7 is the most anterior located one. We can already recognize some cytoarchitectonic characteristics just by looking at the histological section. In this case, you see the typical ribbon structure of area ID6, which is unique in the human insula. So area ID6, which you see on the left side, can be characterized by high cell density in layer 5A and low density in layer 5B, resulting in this typical ribbon structure I just presented to you. In comparison, area ID7 has more density in deep layer 3 and 4, as well as a more compact layer 6. We can now use our probability maps to interfere them with functional data. In the given example, you see insula activation by social and emotional domain, summarized in the meta-study of Florian Kurt. And as you can see, area ID7 and ID6 are most likely to represent the basis of social and emotional processing in the insula. Another example is area ID4, which can be identified by large homogeneously distributed pyramidal cells in layer 5, as well as a superficial to deep increase of cell somata size in layer 3. And as you can see on the left side, it can be associated with insular motor functions. So now I want to summarize my talk, as I presented to you a complete map of the isocortical part of the insula is now available. The general classification of mesolam into a granular to agranular sector was confirmed, but with a new mapping approach, a more diverse passillation of the already known sectors was discovered. Besides, our maps considered inter-individual variability within the 3-dimensional reference space, and they enable an accurate structure-function relationship in the 3-dimensional reference room. So our results will be integrated into the Human Brain Project, as well as the U-Brain Atlas and the Anatomy Toolbox by Simon Eickhoff. And you can easily find those links in the online version of my presentation if you want to use our data for your own projects. Last but not least, I want to thank my colleagues who helped me establish this work, especially Svenja Kaspers and Katrin Ammunds for always providing advice, Francesca Ernili for mapping Area ID7, and Sebastian Bluder as well as Hartmut Mohlberg for processing our data. And I want to thank you for your attention and the opportunity to present our work on the stage. And if you're interested in more information about Insula's cytoarchitecture, I will be very happy to welcome you at my poster on Thursday. So thank you very much.
Time for a question.
We believe that the dorsal part of the anterior insula is taste. So it might have a pronounced layer for perhaps superficial layers. We believe that the visceral insula, which is so often implicated in emotion studies, is ventral to that. So you might expect a pronounced layer 5. Do you see anything like that?
You mean a pronounced layer in the anterior area of the anterior insula?
Anteroventral, we think, is visceral.
Well, we actually, if I rethink, we didn't discover a very pronounced layer 5, to be honest. In one of the areas I presented to you, area ID4, you saw a very pronounced layer 5, but that is connected to insular motor functions. So I suppose in the region which you suggested, we didn't see this, but this is exactly one of those questions you could address with our data. So you could easily use your region of interest and interfere this with our data.
Thank you.